All right, everybody. Aloha and welcome to our TCBES Natural Resources Seminar. I am pleased to introduce our speaker today, Jess Kirkpatrick. Jess was born and raised on the east side of Hawai'i Island and was inspired by the forested environment that surrounded her at an early age. She majored in environmental science at Hilo, graduating in 2012. Right after graduating, she did a pipes internship with the Office of Maunakea Management, now renamed as the Center for Maunakea Stewardship, where she discovered her passion in entomology. She was soon hired by Mgmt, where she worked for 3.5 years before embarking on her graduate journey in the TCBES program. Her thesis focused on the Wēkiu bug, which is endemic specifically to the summit of Maunakea. After graduating in 2018, she was rehired by the Center for Maunakea Stewardship, where she presently works as their natural resource specialist. Her days are spent doing a variety of work, including planting seeds in their greenhouse, monitoring cultural sites, and IDing insects. In her spare time, Jess enjoys surfing, paddling, dirt biking, and gardening at her home in Glenwood. She cares deeply about our native environment, particularly our too often overlooked insect friends. Mahalo for joining us today, Jess, and I will let you start.
All right, mahalo everyone. Aloha. Thank you for letting me speak to you guys. It really is a privilege to speak to you all. I feel like I've kind of done the full circle. Just 5 or 6 years ago, I was sitting in your seat as a student, and here I am now presenting to you folks. So I hope you find this presentation interesting and also inspiring to continue on your journey and to get that degree. All right, so we'll go ahead and get started. I wanted to take a moment just to aloha Maunakea. Maunakea is deeply revered by the people of Hawaii and also people around the world. And everyone has their own relationship with Maunakea, which I think makes it a really special place, a special relationship. And people may go to Maunakea for different reasons. Some people may go to hike, to go hunting, sightseeing. Some people may go up there to conduct scientific research or to conduct their cultural practices. And as land managers, one thing that we try to do is kind of balance all those multiple uses on the mountain while also keeping the public safe, and also trying to protect the resources all at the same time. So that's just something to keep in mind as we move through this presentation. So I just wanted to give a little timeline of how astronomy and management on Mauna Kea came to be. So in the 1960s, the tsunami devastated Hilo and the Hawai'i Island economy. And so the governor and legislature and the county were trying to figure out how to diversify jobs in Hawaii. And so in 1964, they tasked the University of Hawaii to develop research in astronomy and oceanography. In 1978, the Board of Land and Natural Resources granted a 65-year lease of the Mauna Kea Science Reserve to the University of Hawaii. In 1998, there was an audit of the leased land by the state, and they saw a need for increased protection. So shortly after that, in 2000, the master plan was approved by the University of Hawaii Board of Regents, and that established the Office of Mauna Kea Management. Shortly after the management entity was established, a ranger program was established, and then a comprehensive management plan was created, which I'll talk about in a little while, and that was approved by the Board of Land and Natural Resources in 2009. And then in 2012, the resource programs are established. In 2019, the UH Board of Regents adopted a resolution that combined the Office of Mauna Kea Management with the Mauna Kea Support Services and renamed the management entity as the Center for Mauna Kea Stewardship. And just a few years ago in 2020, the University of Hawaii Administrative Rules for Mauna Kea Lands was adopted, which allows us to regulate certain activities on the mountain. All right, so our management area, It totals just over 12,000 acres on Maunakea, and it includes the Maunakea Science Reserve, the road corridor, and also Halepohaku facilities. The Halepohaku facilities includes mid-level facilities, which is where researchers can stay when they're doing their research up on the mountain. Our lands are bordered by the Maunakea Forest Reserve, and then we also have shared boundaries with the Natural Area Reserve as well, which includes Lake Waiau, the Adds Quarry, Keanako'i, and then also this square here, that is where Pu'upohaku is. So that is also within the north. And we also have 3 different types of ecosystems within our management area. Starting from the bottom here, we have a subalpine Lamane woodlands, and then we go up into the alpine Pukiave shrubland. And then above that is the alpine stone desert ecosystem. And these were once designated a little bit differently, but they were rezoned kind of recently by Dr. Grant Garish, who did a botanical inventory on the UH management area. And this photo just kind of shows some of the ecosystem types that you can see. We can see the Mamane woodlands here, and then it turns into the Pukiave shrublands, and then above that is the alpine stone desert. So I mentioned the master plan that was approved in 2000 by the Board of Regents that had established the Office of Maunakea Management. This plan also established a community-based type of management. It created a Hawaiian group called Kukumauna, which is our Native Hawaiian Advisory Group. It also created the Environment Committee and the Maunakea Management Board. So Kukumauna and the Environment Committee are members of the community, and they represent different areas of the community and have different expertise, and they advise the Maunakea Management Board, who are also members from the community, and they have approval authority on different projects that occur on the mountain. The master plan also limited development to a certain area within the Maunakea Science Reserve that we call the Astronomy Precinct. It's a 525-acre piece of land. And it also established a review process for development. And so any kind of projects or development on Mauna Kea has to go through our Cultural Advisory Group, the Environment Committee, and has to be approved by the Mauna Kea Management Board. And just last week, the University of Hawaii Board of Regents approved a new master plan. And that new master plan actually kind of reduces development on the mountain. Some sites can actually be recycled, so there's plans for that. And so we do have a new master plan. I didn't update the presentation based on last week's decision because the first master plan really did establish lots of the things that are ongoing right now. We also have a comprehensive management plan, which is really the guiding document for how we conduct all management activities on Mauna Kea. Within the comprehensive management plan, there are 4 subplans. There's a cultural resources management plan, a natural resources management plan, a public access plan, and a decommissioning plan for observatories. And all of these plans were approved by the Board of Land and Natural Resources, and they're currently in the process of being updated. So both the master plan and the comprehensive management plan are plans that guide all of our management activities on the mountain, and we need to make sure that we comply with these plans. And within the comprehensive management plan, we have 103 management actions. So all of our activities that we do on the mountain aims to address these management actions. And I wanted to just kind of share some of those management actions with you. These are the natural resource management actions taken right out of the plan. And there's things like maintaining native plant and animal populations and biological diversity. So they give kind of one line management action, there is more comprehensive detail in the comprehensive management plan. But even though they're just one management action, there's lots of activities that are tied to these actions, and a lot of these actions are overlapping. So like I mentioned, these are things that are going to be updated because some of these management actions have actually been completed. So one of the things that we do as land managers is permitting compliance. So the land on Maunakea is owned by the state. It's overseen by the Department of Land and Natural Resources. The University of Hawaii holds the master lease for the land. The Center for Maunakea Stewardship, we are the land managers. Now, every observatory has a permit. This is actually considered a conservation district. So each observatory has a conservation district use permit, and that permit is held by the University of Hawaii. So the Center for Maunakea Stewardship, one of the things that we do is we make sure that the observatories comply with the guidelines of their permits and also complies with all of our management plans. Another aspect of management is the Maunakea Ranger Program. This is kind of the most recent picture we have of our rangers. It doesn't include all of them, but it includes most of them. They may look just like some ordinary guys, but I think these guys are pretty extraordinary. They work long hours. A lot of them have past experience as firemen. We also have someone that used to be in the Coast Guard. They're retired police officers. And they are really there for public safety. They give public safety briefings to all of the vehicles that are going up to the mountain to make sure that everyone knows that the hazards and that they know how to use their four-wheel drive and downshift. They are also the ones that do the road checks to make sure that the road is safe for the public to go up to the mountain. They're really our eyes and ears on the mountain. They're also the first responders for accidents, for lost hikers. And on snow days, they're extremely busy trying to make sure people are safe. Snow play can be very fun, but it can also be very dangerous. Another part of management is road maintenance. We have a great road maintenance crew that are up there to help clear the road, to make ways and for observatory personnel to get up to the observatory, and also for the public to get up to the mountain. They maintain the road a couple times a week. They make sure that the signs are all intact and people can see those signs. And they're also up there in blizzard type conditions trying to clear the road. I'm going to shift gears into our cultural resources program. Our cultural resources program works closely with Kukumauna, our Hawaiian advisory group. And really the focus of the cultural resources program is historic properties. So historic properties are defined as a building, structure, or object that's greater than 50 years of age. And these historic properties are protected under the State Historic Preservation Division. And in 2005, the Office of Maunakea Management conducted an inventory of the Maunakea Science Reserve and the access road. And they identified over 250 historic property sites. And then in 2014, the State Historic Preservation Division approved a long-term historic property monitoring plan. And this plan identifies the frequencies on which to monitor all of these sites. Some sites are monitored on an annual basis, a 3-year basis, and then also a 5-year basis. And to date, there is no other agency in Hawaii that has a historic property monitoring plan comparable to ours in terms of the sites that we go to and the frequency in which we visit these sites. So these are just a couple examples of historic properties. Some of them, 50 years of age isn't all that old. So some of them are benchmarks. Some of them are these stone cabins. This is actually what Haleʻohaku was named after, was these stone cabins here. But a lot of the sites, the vast majority are cultural sites, archaeological sites. So we have, in this picture here, it shows a pounding stone. We also have preformed adze. There's a pile of some preformed adze. We also have uprights. And there's also rock shelters. And so what we do is we go out with the archaeologists and we document any changes to these sites. So in the past, there have been reports of people taking uprights or adze and actually selling them off of eBay. And so we go out to these sites to make sure that they haven't changed over the years, that they haven't been impacted by anything, and that the site still remains intact. And when we go out to these sites, we also document any of the flora and fauna that we observe within a 5-meter radius of the site. So that includes some lichens, ferns, some of the native grasses. And we also sometimes come across a Hawaiian wolf spider, introduced ladybugs, and also some really interesting native insects as well, such as this is a stink bug, a native stink bug. And so recording the flora and fauna is a really good way to kind of understand what's going on out there, especially in the science reserve, because these sites are pretty far away. Some of these sites take 3 hours to hike to, and that's just hiking one way, so then we have to hike back. So it really allows us to understand really what's going on in our management area. All right, so I'm gonna switch gears into our natural resources program. The main thing that we do in our resource program is really looking at invasive species management. Everything kind of revolves around that. We also conduct native species monitoring. We do native plant restoration activities, and we participate in community outreach. So we have our invasive species management plan. This is actually one of the management actions that are called out in the comprehensive management plan. And so our management plan, it includes various sections. Prevention is actually key to managing invasive species. If you can prevent them from getting there in the first place, then you have it's going to be a lot cheaper, and you're going to spend a lot less effort if you can prevent the invasive species from getting there. Then we also have what we call early detection. So we have surveys that we do to try to detect invasive species before they become established, because if you can detect them early on, then you can potentially control them or eradicate them so that they don't cause harm down the road. The plan also outlines monitoring. So there are some invasive species that, we know that we won't be able to eradicate, things like fireweed or mullein. We know it's up there, so what we do is we monitor. There's also a section in the plan for control. So how do we control invasive species? And then we also have a rapid response section. And I'm gonna get into all these sections and kind of tell you how we go about conducting these management activities. The plan also includes standard operating procedures for how to conduct all of these different activities. And the plan also identifies threat taxa. So one of our number one threats on the mountain are actually ants. We have no native ants in Hawaii, and all ants are introduced, and any ecosystem they become introduced in, they can have detrimental impacts on the native ecosystem. The sheer number of ants, they can outcompete, they can predate on our native species. And to date, there is no other agency in Hawaii that has an invasive species plan that's comparable to our invasive species plan, just in terms of the level of efforts that we do, our frequency of monitoring, things like that. All right, so first I'm going to jump into prevention. So how do we prevent invasive species from getting up to the mountain? Well, for equipment and supplies, anything that's larger than what one person can carry, it requires an inspection from a DLNR approved biologist. Currently, I'm the only one in the office that can do these inspections. We also do inspections of large trucks that have 3 or more axles. And when I do these inspections, I'm looking for animal, plant, and earthen materials. So if your vehicle is muddy, you're not allowed to go up to the mountain. You're gonna have to clean your vehicle. If your vehicle has a whole bunch of weed seeds that are usually attached to mud, they're not allowed to go. And if their vehicle has a whole bunch of ants everywhere, inside or outside, they're not allowed to go until they remediate the issue until it's re-inspected. So I actually issue certificates showing that they have actually gotten approved to go up to the mountain, and our rangers actually check to make sure that they have gotten inspected. Anything that's stored outside for a period of time would require bait in the inspection, and we use peanut butter, jelly, and Spam to bait. Those 3 types of baits, most ants will come to one of those 3 types. We have the carbohydrate, the lipid, and the protein. So ants are just like us. They like the same things that we do. Another way that we prevent invasive species from getting up to the mountain is through the cleaning of vehicles and personal gear. And so all observatories have to comply with our invasive species plan. And so they need to clean their vehicles monthly, as do we, all the staff that work up on Mauna Kea. And they also have to ensure that their personal gear is clean. Since our rules have been adopted, we can actually apply this also to the public. And so our rangers will actually turn away vehicles if they are muddy. And people are upset about that, which I understand, but we're trying to make it more aware that when you come up to the mountain, we want you to keep your invasive species at home, and we want you to have clean gear and vehicles. Okay, now we're shifting gears from prevention. Now we're going into early detection and monitoring. So we do a couple different types of early detection and monitoring. We do facility monitoring. And we do facility monitoring both monthly and quarterly. So we always have traps out in areas where there's people, because people are the ones that actually bring invasive species. So at Halepohaku, we always have traps out. We replace them monthly. And then for all the other observatory facilities, we place 59 traps total, and we place those quarterly. We keep them out for a week, and then we go and retrieve them. And we put these traps in the facilities in areas like the kitchen, areas near like loading doors where they're going to load equipment and things like that. Potential areas where we're going to see invasive species first. And these are the traps that we use. They're actually like those hoi hoi sticky traps. We cut them in half and we bait them with our favorite peanut butter, jelly, and Spam. And then as part of the facility monitoring, we also do perimeter searches around every single perimeter, every single facility perimeter, and also all the parking lots, because parking lots are great places to find invasive species, because people come up with all kinds of things in their vehicles. Some people will unload their vehicles, trying to reorganize. And then also we make sure we do perimeter searches near trash cans as well. And for our perimeter searches, we actually use baited bios, baited again with peanut butter, jelly, and Spam. We place them about 10 feet from each other around the perimeter of an area. We also remove invasive weeds while we do this, because invasive weeds are habitat for invasive arthropods. So things like aphids, we'll find aphids on the roots of these weeds, and aphids and ants have a relationship together. The ants will actually tend to the aphids. And so by removing weeds, we're also kind of making sure that we're not seeing invasive species that are associated with those weeds as well. The aphids are not a problem, but it's the ants that attract. But the ants are attracted to the aphids. We also do, like I mentioned, we do the historic property monitoring where we document the flora and fauna. At those sites, we also put out baited bios. Some of those sites will have offerings, and some of those offerings are plant materials and things like that that could potentially harbor invasive species. So that's another place where we do early detection and monitoring. Now I'm going to switch gears into monitoring and control, since we're kind of talking about facilities. So we do have the European honeybee up there on Maunakea, and in most places, you know, it's not really too much of a threat. But on Maunakea, the European honeybee actually competes with our Hawaiian yellow-faced bees. And so we set up these traps. It's like a cardboard trap, and we put them in momane trees to kind of provide habitat for the European honeybees. And then once we see that there's activity, at least for 2 weeks, because if we wait for 2 weeks, that will allow a queen to become established. So once we see activity in these traps, we actually relocate them to a bee farm in orchid land. And the reason why we do that is to kind of take the pressures off the mountain. And we also, you know, we also do this for public safety, to kind of give the bees an area temporarily until they become established so we can remove them. We also place these Y traps, the wasp, hornet, and yellow jacket traps, and that is to control yellow jackets. Yellow jackets are extremely predacious, and they can also be very aggressive. And actually, some studies have looked at the gut contents of yellow jackets, and they have found our native Hawaiian yellow-faced bees in their guts. There's also a relationship between honeybees and yellow jackets. Yellow jackets will actually steal the resources from honeybees. So if we keep the honeybee populations kind of under control, then we can also keep the yellow jacket populations under control as well. All right, another part, so I'm kind of jumping around, I'm going back to early detection and monitoring. Another part of that is annual arthropod surveys. We do these surveys every summer. We do them in the summer months because insects are just like us, they like the warmth. They're not going to come out if it's too cold. So we do this every summer. We've been doing these surveys actually since 2001, and the invasive species part of it, we started doing that in 2007. And this map shows our sites. We have a total of 111 sites, and it includes the natural area reserve. So we include the natural area reserve because there's Lake Wēkiu, there's a body of water, and that is definitely a site where invasive species are going to be attracted to, because water is a limiting factor up there on Maunakea. So we have a variety of traps to catch different types of insects. And depending on where the sites are, we set a few different traps in those areas. So areas where we know that there are Wēkiu bugs, we don't set unbaited pitfall traps. So this is an unbaited pitfall trap right here, and it captures any insects that are just kind of crawling along the surface. And we don't put these in Wēkiu bug habitat because we don't want to kill any Wēkiu bugs. And this trap has propylene glycol in it. The propylene glycol, it reduces freezing at night. It also reduces evaporation, and it also acts as a preservative to preserve the insects until we pick up the trap. We also have a peanut butter, jelly, and spam stick, and that's to detect ants. We also have a baited pitfall trap, and this is how we catch our Wēkiu bugs and other native species. Our baited pitfall trap is baited with tuna, and it's actually a 2-cup trap. So there's actually a cup at the bottom, and we put some water in there, and it has a wick that goes into the top cup. So this trap works as a live trap, and it can keep insects alive for up to 4 days. And then we have our yellow pan trap, and that captures insects that are attracted to the color yellow. So those are usually flies and wasps. And wasps are a species, a potential threat species. identified in our invasive species plan. So for these annual arthropod surveys, especially in the science reserve, a lot of these sites are up cinder cones. And so we hike up these cinder cones. We usually place traps on our way up to the cinder cones. We use the same sites every year. And then we go and we retrieve the traps 3 days later. And so it's very field intensive. We also record any vegetation in our area. And in the science reserve, especially on the cinder cones, there's not a lot of vegetation, mostly lichens. But we do occasionally see some native grasses up there as well. And also associated with the traps, we also do a hand search. I'm not sure if I mentioned that, but we do hand searches, just kind of looking for any other arthropods in the area. And although this is, we're looking for invasive species threats while we do these surveys, we're also monitoring for native species at the same time because we're already out there. So we might as well put the extra effort and monitor the native species as well. So this is a picture of me. I use an aspirator, which is like a bug sucker, and I'm actually sucking up Wēkiu bugs. And so these traps are live, the Wēkiu bugs are live when we suck them up. And I actually identify the life stage. There's 5 life stages before they become an adult. Once they're an adult, we can actually identify if they're male or female. So what I do is I suck up a bug and I relate to my partner what life stage they're at and what their sex is if they're an adult. Sometimes we also capture pairs. So this is a mating pair of a Wēkiu bug, a female and a male here. And we record that as well. Sometimes we also capture our Hawaiian wolf spider. And they like to eat Wēkiu bugs. So whenever we have one of those, we usually just see Wēkiu bug legs. And then we know that we actually did capture more bugs than what we found when we came to the trap. We also sometimes capture one of our native caterpillars, Agrotis pulmana. It's actually a species that we just recently described. They're also attracted to the stinky smell of tuna. And once in a while, we'll capture some specid wasps. These are a native wasp that we find at a little bit lower elevation. So once we do all the field work, we do all the field work in the summer months. It takes us about 2 months to conduct all the field work. Then we get to process all the specimens that we collected. And so for all the specimens, we identify the taxa to the lowest taxonomic level necessary to determine threat status. And so things like flies, we just identify them to family because they're not a threat according to our invasive species management plan. And then any new threat taxa are identified to species level because we need to identify what they are and then do more research to figure out if we should take some kind of rapid response action to control the new threat taxa. We also have to get accurate counts of everything that is collected in our traps as part of our permit. So we have permits from DLNR to do this kind of activity. And then we save approximately 20 of the voucher specimens from each year so that we have a reference, but we also send some to the Bishop Museum so that they have a reference as well. And then we have to enter all the data. And this is a lot of data. So sometimes it's 10,000 lines of data for 1 year. And so this picture right here, it shows, this is from a yellow pan trap. This is one yellow pan trap. Sorting all these specimens can take a whole 8 hours of your day. And then we have to identify it and document and everything. So the processing time is a lot of time, and we usually do that in the winter months. All right, so I want to switch gears a little bit and talk about the Wēkiu bug, which is something that we monitor every year. So it was listed as a candidate endangered species back in 1999, and then it was removed from its candidate status in 2011 with various research that was conducted and surveys that identified a much broader habitat range than we previously thought. And so Wēkiu bugs' presence is confirmed on 17 different cinder cones within the Maunakea Science Reserve. And it was also removed from candidate status because of management's commitment to monitor, protect, and conserve Wēkiu bug populations and their habitat. And so that's why we conduct this monitoring every year. If we see any changes, drastic changes in the population over a certain period of time, then we should maybe change how we're managing the mountain. And DLNR has access to all of our data. And so they're always in the know about any changes in Wēkiu bug populations. And I just wanted to kind of give a little bit of an overview too about the Wēkiu bug. It is a carnivorous scavenger. All of its relatives are seed feeders, but within 20,000 years, this insect has evolved to feed on dead and dying insects that get blown up to the summit of Maunakea. Wēkiu bugs are only found on cinder cones. They are not found in the glacial till area. The cinder cones themselves allow them to thermoregulate. And these are the different stages of Wēkiu bugs. There's 5 immature stages, and they get darker as they get older, and then the adult stages. And this graph just shows Wēkiu bug monitoring. So from 2007, our sampling efforts became consistent. And so we can directly compare all of the years after 2007. All the trapping efforts remain the same. As you can see, Wēkiu bug populations are extremely variable from year to year. And this is the case with other insects as well. Insects are classically known to have extremely differing populations from year to year. And last year was a pretty good Wēkiu bug year. We think that perhaps the extra moisture that we saw over the past few years on the mountain contributed to kind of the increase in Wēkiu bug captures. And then all of our Wēkiu bugs, so we capture, we count them, and then we release them. And so I have just a real quick video of us releasing the Wēkiu bugs. They move really, really fast. And you can see all the immature stages. They're pretty fat and happy. They got to eat some tuna. And that's that white stuff there is all the tuna. Not the best video, but it's still kind of fun. All right, so now I'm going to switch gears into control. So how do we control invasive species? So we do a lot of mechanical control of invasive weeds. And just last year, I'm really proud to say that we removed 10,000 pounds of invasive weeds from the mountain. And so we remove them and we actually take them to the green waste, where they can heat up the green waste to temperatures that will actually kill the seeds. We also do community volunteer weed pool events. And we had to kind of stop that with the COVID, but we hope to resume that soon. And these weed pool events are really fun for the community. It allows people to kind of have a relationship with the mountain. And it's a really fun time. We hope to resume those soon. We also do, only when absolutely necessary, we do chemical control, and we do that on a species-specific basis. And we always research the best method for control because we don't want to inadvertently impact any of the native species up there. And so a good example is in our restoration area, which I'll talk about in a moment. We do control aphids with a safe chemical that doesn't impact the beneficial insects like ladybugs, which actually eat the aphids, so we don't want to impact them. So that's pretty much the only kind of chemical control that we do. All right, so the last section of invasive species management is rapid response. So whenever we have to rapidly respond to anything, if we find a new species we haven't ever found before and it's definitely a threat, we drop everything that we're doing. And we literally rapidly respond to these. We take these very seriously. So the first step is to capture a specimen and get it identified to species, because you need to know what you're dealing with. And then we do delimiting surveys. So we try to figure out exactly where the species are. What is the extent of the species? And depending on that information, it may go to the Emergency Response Management Committee, which is made up of people from our different boards and advisory groups, also people from different state agencies, including the Big Island Invasive Species Committee, and we also get various types of specialists involved depending on the species. And then we determine whether or not eradication is possible versus containment of the species. Then we would have to draft the management plan, and we would have to monitor and report based on what was written in the management plan. And eradication, the definition of it is the absence of 2 invasive species for 2 life cycles. The absence of the invasive species for 2 life cycles of the organism. And so eradication is always a goal, but it's not always a goal that we can reach, but we try. And luckily, all of our rapid response cases haven't been too terrible, and we've actually been able to identify that it was just kind of a very isolated population, or it came up on somebody's boot and it blew into our trap. So we've been very lucky so far, knock on wood. All right, so now I'm going to switch gears into native plant restoration. So we have a greenhouse up there on Maunakea, and that greenhouse was built as part of the visitor information station expanding their parking lot. They had a project to expand their parking lot, and from that we got a greenhouse out of it. So our greenhouse's name is Kale Momane Ho'olu Meakanu. And this greenhouse was built by the hands of the Hawai'i Island community to fulfill our kuleana to the native plants and animals on Maunakea and to connect future generations to life on the Mauna. And so really the idea for this greenhouse is to have community groups come up, help us collect seeds, help us prepare seeds, help us plant seeds, and then help to outplant seeds back into the environment. And that will really allow people to take part on the mountain and build a relationship with the Mauna. And this was completed in December of 2020. So last year, we were able to finish building all of our benches. So we're pretty excited about that. We're still trying to fill in all of our benches with plants. So some of the plants that we've been successful at growing so far is mamane, pavale, puakala, and abelbel. What I didn't include on this list, but I just thought of is our native grasses. We also have 3 different types of native grasses, and we've actually been successful at growing those as well. But we're also trying to grow other things like pukiave. We have our Hawaiian mints, Stenogene microphylla, Stenogene rugosa, and also some other species that are a little bit more rare, things like Dubaudia arborea. We pretty much want to try to grow everything that we see in those alpine and subalpine ecosystems, but we're kind of experimenting with how to do that. And everything that we grow up there, we use the same soil that's already up there on the mountain. So we don't bring any soil from lower elevations because we're worried about introducing pathogens or invasive species. So we're really just using the soil that's already up there. And these are some of our plants in our restoration area. Here we have abelbel, and we've actually seen it set flower and seed, which is pretty exciting. We have mamane, which we actually see it growing all by itself. We're seeing natural regeneration of mamane. We have ena in our restoration garden. This is a native herb and it's kind of taking over, but it's native, so we're kind of letting it do its own thing. We never planted any of it. It just is naturally regenerating all on its own. This is Pavale, which is one of my favorites. It's very beautiful flowers. And we're also seeing Pavale flower and set seed as well. And then we have Puakala, which is our Hawaiian poppy. And that is also flowering and setting seed. All right, so these are some photos from August 2019. This is when the visitor information station, the parking lot was just completed. And as you see, there's no vegetation at all. And then in August 2021, we actually put some jute mat, which is made out of burlap to kind of help with erosion because it is kind of a slope there. And we started planting some of Wēkiu and Momane, Puakala and Pavale and everything else. And this is November of 2021. So just within a couple of years, we've seen significant growth. We're really, really excited about it. Some of the Wēkiu are 4 feet tall already. We did cheat a little bit. We gave them some fertilizer, but they need some love. And so we're really proud of our restoration area. And we also have some signs up, which not everyone listens to signs. But we have some signs up and some chains to prevent people from walking in at least our largest restoration area. And really the goal of the restoration area is to bring the plants to the people. So people need to acclimate at the visitor information station for a half an hour. And so we want to bring the plants to the people. Eventually, we would like to do some guided tours to our restoration area and also have some signs prepared. There's also some challenges in our restoration area. So when we get really high winds, we get some of our Wēkiu get uprooted. We have issues with aphids, like I mentioned earlier. We also have issues with the game birds. They like to munch on our native plants. And so we've actually created some cages around some of the plants that we're getting munched on. Our restoration area, they also have to endure some pretty intense conditions. Sometimes there's frost on the ground early in the morning. We also struggle with managing the invasive species like kikuyu grass. That's definitely a challenge. And there's also the challenge of visitors coming up and not listening to signs. People will trample on little plants and things like that. So that's another challenge in our restoration area. So we also try to conduct as much outreach as we can. It's been kind of hard with COVID. So these are some of the ways that we engage with the community. We also host pipes and turns, which I feel like is a type of outreach and community engagement. We used to host Maunakea speaker series. Every month we would host a talk from a researcher that's doing some kind of research related to Maunakea. We also do weed pool events with the community as well. But we're trying to expand our networks and trying to do more outreach to engage with the community. And then we also fund various types of research projects to better understand our resources on the mountain. So these are just some of, actually these are all the ongoing research projects right now. The one research project I wanted to give a shout out to is the seabird and bats. Dr. Pat Hart has been working on that project, and from that project, they actually detected uwa'u for the first time on Mauna Kea since the 1960s, which is really exciting. It was actually detected outside of our management area, but we're very excited about this research, and this research is still ongoing. So we're excited to see what more he can find about uwa'u. All right, so lastly, I wanted to talk about management challenges. One of the challenges is working up at high elevation. Up there on the summit, there's 40% less oxygen. And so even trying to write your notes up there take a little bit longer than if you're in Hilo. I feel like sometimes I have brain damage from being up there for so long, I can't always put my sentences together when I come down the mountain. So the high elevation is definitely a big challenge. Another management challenge is balancing all these different uses on the mountain while also balancing safety and resource protection. Another challenge is building and maintaining relationships with the community. How do we get people to trust us, and how do we build those relationships? Relationships are a lot of work, and we want to build those relationships. But you know, I think relationship building has to occur on different levels, and so that's definitely a challenge. Another challenge is sharing the work that we do. You know, we can go to outreach events and things like that, but I don't think that's enough. We need to share more of how we do our work, and how we go about sharing that information is not always easy. Another challenge is the politics associated with Mauna Kea. And of course, the controversy that's associated with Mauna Kea. That's a big challenge. Those are things that are way above my head. You know, I got into this profession because I like to look at bugs and manage the resources, but politics and controversy is always there. And then a last management challenge is, you know, there's been a history of mismanagement on the mountain. So how do we show people, how do we change people's minds and show them that we're really trying to do formal management? I think that's really a challenge, and I don't think there's any one answer that'll solve all of these challenges. So it's just something that we're continuously trying to work through. I just wanted to give a shout out to my natural resource team. All the work that we do, I have a very small team. Patty Heidenfeld, she's in charge of our native plant restoration area. And then I have Abby Reedy, and she helps with all different other kinds of management activities that we do on the mountain. So without my team, we wouldn't be able to get all the work done that we do get done. And with that, I would like to say mahalo nui to everyone. I'm happy to answer any questions, and if you guys want to email me anything, feel free. Thank you.